Guys, welcome back in action. This is your brother Abdul Hamanour. We'll be taking through mathematics of high school. Make sure you take advantage on this ongoing program here. It will help you because this is a mathematics of high school which can at least help you if possibility allows for your information. Okay, and then if you will be with me, I'm sure 100%. You'll be learning mathematics from Form 1 to Form 4 for your information. Remember in our previous class we have been distorted by the power of Kenya because electricity went off. That's why I was not able to help you throughout that session. Let's go and see the first example, guys, for information. This is our first example without wasting time. I'll start with this one, your taller. If you have that one, that previous one, let's also start with this one. Yeah, you have the first example will be, this is our example 1. Remember what you're doing is possible questions in KCSE, okay? Just answer here, possible questions that can come in KCSE. Okay, now let's see the taller rectangular tongue. Rectangular tongue measuring 3 meter long, 3 meter long, and 2.5 meter wide. 2.5 meter wide, has a capacity okay, of 16,500 liters. Full stop. 16,500 liters for your information. You're told to calculate the height of the tank in meters. Calculate the height of the tank. Calculate the height of the tank in liters. So this is question A. Remember, this question is carrying what? It's carrying 3 marks. So this is how they frame paper 1 questions of volume, okay? That's question A. Then let's proceed to question B. You're told the above tank is initially, the above tank is initially 1 out of 5 full of water, okay? 1 out of 5 full of water. Okay. Calculate the height of water in the tank. Calculate the height of water in the tank. Okay, this is also carrying 3 marks in KCSE. This question normally comes in paper 1, question 17 or 18. Yes, understand, yeah? Okay, then question C. This is question C. I just understand. This will be our question C. You're told water was added. Water was added into this tank. Until it was 3/4 full. 3/4 full, okay? You have to full stop, calculate. Then from 1, the volume of water added in liters. The volume of water added in liters, okay? This is carrying what? This is carrying 2 marks. It's carrying 2 marks. Then Roma 2, you're told, the increase in height of the water, the increase in height of the water, look at this one. The increase in height of the water in the tank in meters. In the tank in meters. This is also carrying another 2 marks. So the question will be framed like this in KCSE, guys, okay? So the question here is, what are we talking about, okay? Are we talking about rectangular tongue? Are we talking about cylindrical tongue? Okay, those are the two that are framed during national exam, okay? A rectangular tongue or a cylindrical tongue, okay? That is what's framed during national exam. Then we say that a student of mathematics must possess 3 qualities, okay? That is understanding the nature of the question, that's number 1. Number 2, having speed, okay? In case you see on normal exam, you must be calculating very fast, okay? So that you save time, okay? The other thing is what? Accuracy, okay? You know, as you calculate, you must give us the right information, okay? Or the right calculation that will lead you to the right answer, okay? So this is how questions are framed during national exam, guys. We are told a rectangular tongue measuring 3 meters long and 2.5 meters wide has a capacity of 16,500 liters. So if we sketch now this one, I know this direction of light is somewhere here. Let me sketch it here. So let's say this is the rectangular tongue, okay? I'm not good at drawing, but I'll try my best, okay? Let's say this is the rectangular tongue, okay? Let's say this is our rectangular tongue. Remember, this is the length, okay? This one, this is the length. So they say that a rectangular tongue measuring 3 meters long. So this is 3 meters, and it is 2.5 meters wide. So this is 2.5. So what's under question mark? So H. H is under question mark, okay? H is what? Under question mark. So remember, if you go back to primary, in class 6, we have learned this one, that the volume of a cuboid is gotten as base area times height, okay? Now I can get the base area. I'll say base area. But before that, let me take this one. And let me get the base area. Base area is equal to L times W. In this situation, 3 meters times what? 2.5 meters, which is 7.5. Just understand that. It even does not require calculator. 7.5 meters squared. That is the base area, okay? Make sure you have your calculator, okay? When you have the base area, remember I said in our previous class, I said that there must be compatibility, okay? When you have capacity and measurements, okay? From the measurement you can get the area, okay? The base area you can get this. Then convert your capacity into volume. So we know that we have our capacity is what? In this situation, our capacity is 16,500 liters. So I want to convert this one, knowing the relationship that 1 meter cubic is equal to what? 1,000 liters, okay? Having this one in brain, then we can convert this one. 16,500 liters. Cancel. So it will be 1 meter cubic times 16,500. Yeah, 16,500 divided by 1,000. So this will give me 16.5 meter cubic. Okay? That is the volume of the cuboid for your information. When you convert. So you can now get the what you normally call it. So you can get the height. Yeah, of course, yes. Now let me get height. How will I get height? I'll say height is equal to. No, let's go back. Calculate the height of the tank in liters. Yeah, great. H is equal to, now H is equal to volume divided by base area. So H therefore is equal to 16.5 meter cubic divided by 16.5, yeah, just answer, 7.5 meter squared. So this will give me how much? Let me divide this two. It is 16.5 divided by 7.5. Check your time, please. That is H is equal to 2.2 meters. Okay? Remember, you're told in meters. So leave your answer like this. Leave your answer like this. Just answer here. In meters, just leave your answer like this, guys. Okay? Okay, the next question, that's as far as question A is concerned. Then we'll go to question B. They are told the above term. The above term is what? The above term means the term with the capacity of what? 16,500 liters or a volume of 16.5 meter cubic. Okay? You're told the above term is initially 1 out of 5 full of water. Calculate the height of water in the tank. Let me get capacity of water or volume of the water in the tank. Now this is question B. Question B, yes. Volume of water in the tank. volume of water in the tank. That is how much? 1 out of 5 times the volume of the tank, which is 16.5. Okay, that is what? Times 16.5 meter cubic. So it will give me, if I'm not wrong, it will give me 3.3 meter cubic. That is the volume of water in the tank when the tank is 1 out of 5 full. Yeah, just understand. So I can get height of water. Like I say, height of what? Height of water in the tank. In the tank. Be specific, yeah? In the tank. Height of water in the tank will be volume over base area again. Volume over base area. Remember, the volume will not, the base area will not change, okay? So the volume of water is how much? 3.3 meter cubic divided by the base area, which is 7.5 meter square. But remember again, you are told to calculate the height of water in the tank, okay? So they're saying calculate the height of water in the tank. So what are we going to do? We will give them two answers, yeah? One in centimeter and another in meters, okay? So this will be 3.3 divided by 7.5, okay? That is equal to 0.44 meter or 44 centimeter. Provide two answers, please, okay? That's how you're going to calculate the height of water in the tank when the tank is 1 out of 5 full of water, okay? Okay? Now let's proceed to question C. Come to question C. These are possible questions in paper 1, please. When you go to paper 1, question 18, confirm. If not, question 17. So when you have question 17 graded, then question 18, obviously it will be volume. Just confirm, okay? Then we'll be discussing about ratio because it will be there also in paper 1. Now you are told question C. Water was added into this tank. Which tank? Until into this tank what? Yeah, the tank which contains what? 3.3 volume of 3.3 meter cubic. So you're told, but you can still get, you're told water was added into this tank until it was 3/4 full. Calculate the volume of water added in liters. Okay. Now, remember, in liters, yeah, just cover. So I will say C, volume of water in the tank when it is 3/4 full. Be specific, yeah? So that will be, this will give me 3 out of 4 times the total volume, which is what? 16.5, okay? 16.5. So this will be how much? Let me confirm. It will be how much? 16.5 times 3 divided by 4. So this is 12 point. It will be 12.375 meter cubic. So you are told, look here, understanding the nature of the question is very important. The volume of water in liters that was added. Because the tank was what? The tank was, it was what? The tank was 3.3 full, yeah, 3.3 meter cubic full water, 3,300 liters was there. So now, let me get now, volume of water added. Volume of water added. It will be how much? 12.375 meter cubic minus 3.3 meter cubic. Okay? Minus 3.3. That is 9.075 meter cubic. But you are told in liters, okay? You are told what? In liters. We know that 1 meter cubic is equal to 1,000 liters, okay? What about this one? 9.075 meter cubic. Cancel. So it will give me 9.075 times 1,000, which will give me finally 9,075 liters, okay? That will be the final answer because we have to subtract, just understand. So this is the volume of water that was added, okay? Okay, in liters, just understand. Then the increase in height of water in the tank, look at that. How are we going to get that? Okay? This one, let me get height when volume was 9.075 because when it's 3/4 full, it will, no, sorry, when it's 3/4 full, Or we can still get from this one, because remember, you are told, look at that, the increase in height. See, you can get from this one. Or what you can do is get height when the volume is this one, then subtract from the initial height, okay? You can also do that. Or, so far you have the difference in volume, because where this is the, and this is the increase in volume, okay? So when this is the increase in volume, we can get height, okay? That increase in height, you can say, that is what, Roma 2, okay? This was C Roma 1, not 2 again. This is C Roma 2 for your information. So increase in height. Increase in height of water is equal to volume, increase in volume divided by base area again. Okay, so you can say 9.075 meter cube, which is the increase in volume, just understand here, divided by volume of water, increase in volume of water, divided by base area in this situation, 7.5. Okay, so that would be the increase in height. You can use another alternative method, but you can still get the final answer using also this one. That is, it will be 1.21 meter. Okay, that is the increase in height. Okay, increase in height of water. That is the final answer for your information, guys. I hope you are with me. Okay, I hope you are with me. Okay, make sure you digest this thing, please. Understand the nature of the questions. Okay, we will go back and see another. We'll go back to the book and see another example. Okay, and how it's during national exam for your information. I hope you are digesting this thing. Very, very hospitable. Yeah, very get don't get confused. Yeah, when you come to this point, because there's an increase in height of water, what are we going to do? We are going to say, for your information, we are going to say that the increase in volume is what? In volume of water is what? This minus this, which will give us 9.075. So if this is the increase in volume of water in the tank, see, we can get the increase in height of water. Yes. So if increase in volume divided by base area will give us the increase in height. Alternatively, you can get the height of water in the tank when the volume is this one. Then after you get the height when the volume is this one, then you subtract from the initial height, which was what? 2.2, then you'll get the same answer, 100%. Okay. Now let's go and see the second example without wasting time, guys. You'll go and see our second example, okay? Let's see. I hope you're digesting this thing. Very, very welcoming, okay? Make sure you have your exercise book, your calculator, as well as your pens, okay? Let's go and see the second example without wasting time. Let's go and see the second example. Let's go. I'll be giving you videos, live videos that will help you during national exam. I think, if I'm not wrong, all students are on holiday currently, apart from those who are doing KZZ, our national exam, okay? Those are tested today for your information. They are doing paper 1 and paper 2 of English. Most probably the mathematics will be coming next week, okay? Math and chemistry will be there next week, okay? Make sure, guys, you take advantage of this ongoing program, because it's going to help you, okay? I will give you plenty of notes that will help you solve your problem during national exam or any other exam for your information, guys. Okay, let's go. Let us go, guys, okay? Let us see our second example. Let us see our second example for your information. This is example 2 for your information. This is our example 2. We are told a school water storage tank. A school water storage tank. Okay. Measuring 2.8 meter long, comma 2.5 meter wide, 2.5 meter wide, and 2 meter high. And 2 meter high, has a capacity, you're told high, contains water, to a depth of 50 centimeter. To a depth of Understand this one, please. 50 centimeter, okay? Full stop. You are told question A. Calculate then the capacity of the tank in liters. Number 1. The capacity you are told the capacity of the tank in liters. It is carrying 2 max. Okay? Then the next one, the volume of water in the tank in liters. Number 2, the volume we are told the volume of water in the tank in liters. The volume of water in the tank in liters. Then number 3, let me change this one. Number 3, I told the volume of water required to fill the tank. The volume of water required to fill the tank. Remember, this also carrying 2 max. This one, let me write here. This is carrying 2 max. This is carrying 3 max, okay? So we are left with 3 max, okay? Question B, look at this question. Question B, I told water was pumped. Water was pumped into this tank, at the rate of 1.25 liters per second. Full stop. Your told no, not full stop. Starting at 11:50 a.m. Okay. Then period. Your told determine the time in the 24 o'clock hour system. The time in the 12, not 24, sorry, in the 12 hour clock system. Clock system when the tank was filled. When the tank was filled. Okay? When the tank was filled. This is carrying 3 max. So this is how they frame during national exam, okay? During KCSE, okay? A very fantastic question, but very welcoming also, don't forget. You are told a school water storage tank measuring 2.8 meter. So coming to the solution, come here please. So I will sketch. This is the time, let's say. I'm not 100% artist, but I'll try my best. Okay? Let's say this is the tank. Okay? If you have problem with mathematics, don't worry, guys, okay? I'll take you to Form 1. You will read up to Form 4. This is Form 1. And I'm sure 100% in your schools you have not done this one. This is Form 1, and it will be there in pieces again. It's unfair, okay? It's unfair not to teach students in school and give them the hardest question during the exam, okay? Yeah, we are not blaming the examiners, okay? Or the setters. We are blaming our teachers because They are not going for the application, just understand. So you're told it is 2.8 meter long, 2.8 meter long, then wide is what? 2.5 meter, and the height is what? 2 meter. So this is the three-dimensional, just understand. We can get the volume. We will start with volume, just understand. We can say volume. Let's say that. Let's get the volume of the tank. Yeah. Let me get volume of the tank. So I'll say volume. Let me write that. Volume of the tank. It will be L times W times I. Make sure you write the formula. Or you can say base area times height. Okay, which is now 2.8 meters times 2.5 meter times 2 meter. It will give us how much? I think it's 1.4. 2.8 times 2.5 times 2. That is 14, sorry. 14 meter cubic. That is the volume, yeah? Just answer. But understand the nature of the question. Question 1, you are told the capacity of the tank in liters. Capacity. So we're going to say capacity of the tank. So I'll say 1 liter. No, sorry. 1 meter cubic. I'll say like this. 1 meter cubic is equal to 1,000 liters. Have this relation in brain, don't forget. Then what about 14 meter cubic? Cancel. So this will give me 14 times 1,000 liters, which will give me 14,000 liters. Okay, that is the capacity of the tank in liters. We are done with question A. No, question A number 1. We are done with question A number 1. Then we will proceed to question A number 2. We are told the volume of water in a tank in liters. The volume of water in the tank in liters. Because you are told, look here, come back to the question here. You're told a school water storage tank measuring 2.8 meter long, 2.5 meter wide, and 2 meter high contains water to a depth of 50 centimeter. So this is the height of water in the tank, okay? Then I can get volume of water in the tank, okay? Then I'll convert. Yeah, that's what you're gonna do, yeah? The volume of water in the tank. Yeah, let me get that. Question number 2, volume of water in the tank. How are you going to calculate? Because the height is somewhere here, 0.5 meter, because it is 50 centimeter, okay? If this is the total height, just understand, yeah? If the total height is 2 meter, but maybe the height of the water is 0.5 meter. So you can get height of water by saying base area times its side. So equal to, you're going to say base area times height of water. Times height of water, be specific. Okay, it will be 2.8 meter times 2.5 meter times 0.5 meter, because that is the depth of the water. The height of the water, just understanding the tank. So it's 2.8 times 2.5 times 0.5. That's 3.5, okay? It will give us what? 3.5 meter cubic. So that is the volume. The volume of water in the tank in liters again. Now let's convert. You're going to say if 1 meter cubic is equal to 1,000 liters, what about 3.5 meter cubic? So cross multiply, it will be 3.5. Cancel this to times 1,000 liters, which will give us what? 3,500 liters. That is the final answer for your information. Okay. Then you are told the volume of water required to fill the tank. Now, we know that the capacity, the volume of this tank is 14 meters. And the volume of water in a tank is 3.5, okay? Understand the nature of the question, please. You are told the volume of water required to fill the tank. That is the amount of water which is left to fill the tank. How are we going to get that? We are going to say the volume of the tank is what? 14 meter cubic minus the volume of water in the tank. In this situation, the volume of water in the tank is what? 3.5, because the height was 0.5. So volume required to fill the tank. Volume required to fill the tank. Volume required to fill the tank will be 14 meter cubic minus 3.5 meter cubic. So that will give me 10.5 meter cubic. 14 minus 3.5. Let me confirm that. 14 minus the final answer. That is 10.5 is 10.5. So this is the volume required to fill the tank in liter, okay? Just understand. But they're saying the volume of water required to fill the tank, okay? Now, I need to convert this one. Why? Why are we going to convert this one? Just understand. Because look at this question. When you go to this question, understand the nature of the question. Yeah? Why is it that there's that necessity of converting this, okay, into liter? Because you're told this is the amount of volume, the amount of water that's left to fill the tank, is it? Yeah. Or the volume of water that is required to fill this tank, which is 3.5 meter cubic full, okay? You're told, look at the rate of pumping. You're told water was pumped into this tank at the rate of 1.25 liters per second. So that means per second, 1 second is equal to what? 1.2 rate of pumping is what? Let me write that. Okay, let me convert this one because I know what I'm pumping is in liters, okay? Now, volume left in liters. Volume required to fill the tank in liters. Required to fill the tank in liters. You need to convert this one. It will be 1 meter cubic is equal to 1,000 liters again. What about 10.5 meter cubic? Cancel. It is 10.5 times 1,000 liters. So this will give me 10,500 liters. Okay? That is the volume required to fill the tank in liters. Why are we converting? Because our rate of pumping is in liters. Okay? But say like this. But 1 second is equal to 1.25 liters. This is the rate of pumping. Okay? 1 second. Just understand that this is 1. Okay? 1 second is equal to what? 1.25. What about this one? For how long will it take? 10,500 liters. For how long will it take? Cancel this thing again. So it's 1 second times 10,500 divided by 1.25. Okay, let me get the time taken. 10,500 divided by 1.25. So gives me how much? 8,400 seconds. It is what? 8,400 seconds. Let me convert this one again. But, inform them again, but 1 minute is equal to what? 60 seconds. What about 8,400 seconds? Okay? Look at this one, cancel. So it's 1 minute times 8,400 divided by 60. So this will give me how much? Divided by 60, it will give me 140 minutes. 140 minutes or 2 hours and 40 minutes. No, 2 hours and 20 minutes. Check your time. 140 minutes, 2 hours and 20 minutes, okay? Then you are told determine the time when the tank in 12 hours, time when the tank will be full. Time when the tank will be filled. When the tank will be filled full. It will be starting time as well. Yeah, 11:50. So you're going to say 11:50. Check your time here, please. Check your time. 11:50 plus 2 hours and 20 minutes. Obviously, this is 0, 1, 14. In 12, yeah, minus 12 again. So this will give me 210 BM. This is when the tank will be full to capacity. Very, very hospitable. Yeah? Now just this thing, guys, wherever you are. If you are in USA, if you are in Canada, Australia, wherever you are, or this contaminated world, digest this thing, yeah? Look at this point. Because we need to get time taken to fill the tank. That is 8,400 seconds. Convert this one into minutes, okay? We know that the relationship is what? 1 minute is equal to what? 60 seconds. Then from there, we're going to get 140 minutes, which is equivalent to 2 hours and what? 2 hours and 20 minutes, okay? Then add to the starting time, okay, to get the time when the tank will be full to capacity, okay? Very, very hospitable. That's easy now. Okay, remember this is a live streaming class, so we don't have to problem with time. You are there, I'm sure 100% to calculate everything, okay? Now let me go and see another one. Let me go and see another one, guys. Let's go and see another one, okay? Okay, concerning about this rate of family, okay? I think this is very useful. Yeah, I'm sure 100% you'll be there with me during such kind of sessions, okay? It will help you in KCSE or any other exam. This is very easy, very hospitable, okay? We'll be dealing with the mathematics until we realize that we have done everything, okay? Or we have completed everything, okay? In high school. Now, let's go to example 3. Very, very fantastic class, okay? Let's go and see example 3. Let's go and see our example 3, guys. If you have problem with mathematics in high school, okay, you are unlucky. Not take back this ongoing program, okay? You are very unlucky, guys, okay? Let's go. You will not have problem with volume from today. Then tomorrow we will tackle what? Integers, okay? This live video will be there during Saturday, Sunday, every day of the week, okay? Okay. But we will be dealing with the mathematics, okay? Of live videos during Friday and Thursday and Friday during daylight like this time. But the other time, okay, the other days of the week we'll be dealing at night time, okay? Okay. If not, I'll let you know. Let's go, guys. Let's not waste time. Let's not waste time. Time is the best cancer, don't forget. Time, what reason cannot tell, time can tell, friends. So let's respect time, okay? Let's respect time. Let's respect time, okay? Now let me fuel this thing. Let me fuel this thing. Let me fuel this thing. Okay. I'm done with fuel, yeah? We can start our challenge now, okay? Let's go. This is example 3, yeah? Okay, let's go, guys. Let's go. Your turn, eh? Let me use this one. Your turn, a rectangular tongue. Okay, your turn. This is example 3. Clear witness here. Your turn, a rectangular tongue measuring 2.5 meter. A rectangular tongue measuring 2.5 meter long, okay, comma, 2 meter wide, and 1.68 meter high. Is initially a quarter full of what? Water. Beer. Now let's go. You're taller. Question A. Calculate. Then number 1. You're told the capacity of the tank in liters. The capacity of the tank in liters. So this is called 3 max. Mathematics is fair, friends. Then we will proceed to number 2. You are told the volume of water in the tank in liters. The volume of water in the tank in liters. It's also carrying 2 marks. This is how they frame the national exam. Then we will go to question B, which will be carrying 5 marks here. Starting at 9:30 a.m. 9:30, yeah, this is 9. 9:30 a.m., comma, water was pumped. Water was pumped. Water is pumped, sorry. Water is pumped into the tank above. Into the tank above. Okay? At the rate of 1.4 liters per second. 1.4 liters per second. Full stop. Find the time when the tank will be full. Look at that. Find the time when the tank will be full. Period. This carry out 5 marks. Okay, let's go. Okay, let's go, guys. Very hospitable again. Understanding the nature of the question is very significant. Okay, you're told that a rectangular tank measuring 2.5 meter long, 2 meter wide, and 1.68 meter high is initially a quarter full of water. It's not completely full, so we are left with 3/4 of its volume. Okay, you are told it's a quarter full of water. So what are we going to do? Come here, guys. Okay, where's that one? Let me use this one. So let me sketch for us. Okay, it's what? 2.5. I don't know why they are always starting with 2.5. Yeah? 2.5 meter, 2 meter under, 1.68 meters. Okay? This is 2 meters, yeah, don't forget. And this is what? 2.5. So you can get the volume. Yeah? You're told what? You're told the capacity of the tank in liters. So let me get volume first. Volume of the tank. I'm going to say base area times the height, which is now 2.5 meter times 2 meter times 1.68 meters. So let me get 2.5 times 2 times 1.68. So that's going to give us, it is 8.4 meter cubic. 8.4 meter cubic. That is the volume, okay? That is the volume of the tank, okay? Then you are told the capacity. Understand? So we have to convert this one. We have to say 1 meter cubic is equal to 1,000 liters. What about 8.4 meter cubic? Cancel. So it's 8.4 times 1,000 liters, which is 8,400 liters, okay? This is the capacity of the tank, okay? The capacity of the tank when it's full, okay? So you're told the volume of water in the tank in liters. But you're told, come back to the question, you're told it's a quarter full of water. So you're told the volume of water in the tank in liters. Volume of water, this is the capacity of the tank. Then this is Roma 1. This is Roma 2. Then say volume of water. Volume of water in the tank in liters. That will be a quarter times 8,400 in liters. It will give you how much? I think that's 21. 8,400 divided by 4. 2,100 in liters, okay? That is the volume of water in a tank in liters, because it's a quarter full. Understand, yeah? It's what? A quarter full. So when you have this volume, what are we left with? We are left with 3/4. So you're starting at 9:30 a.m. So, but remember we are left with 3/4. So let me get that one. Because I was not asked, but it will be helpful when you go to beer, in our section beer. So I'll say volume of water left. It will be 3/4 times 8,400 liters. So that will give me 6,300 liters. This is the volume of water that I must be into the tank so that, or I must pump into the tank so that the tank becomes what? Full. Okay, let's go. We are starting at 9:30 a.m. We have started pumping of water into the tank at this time. So you're starting at 9:30 a.m. Water is pumped into the tank above at the rate of 1.4 liters. But say rate of pumping. Rate of what? Rate of pumping. That's what? They say about 1.5 liter per second. So that's 1 second is equal to 1.4 liters. In every second we are pumping in what? 1.4 liters. So if now we are going to say, if 1 second is equal to 1.4 liters, what about this one? 6,300 liters. For how long are you going to take? Cancel this thing. What are you waiting, guys? Cancel this thing. So you're going to say 1 second times what? 6,300 divided by 1.4. Let me get the correct answer. 6,300 divided by 1.4. 4,500 seconds. Okay? Let me convert into minutes. So I'll say 1 minute. Time taken, yeah? 1 minute is equal to 60 seconds. Okay? What about, what about 4,500 seconds? What about this one? Cancel. So it's 1 minute times 4,500 divided by 60. Divided by 60. So that will give me 75 minutes or 1 hour and 15 minutes. Okay? 1 hour and 15 minutes. Time, say now. Time when the tank will be full to capacity. It will be, starting time was what? Was 9:30. It will be 9:30 plus 1 hour and 15 minutes. So that will give me 10:45 a.m. This is the time where the tank will be full. We are adding, remember, this is plus. Don't forget. So this is how KCSE questions based on volume are framed, okay? During national exam is enough. Very, very hospitable, okay? Very, very welcome. What are you waiting, guys? Shall we add another one? Because we are not running out of time, okay? Can still get everything right, guys, okay? Okay. Sometimes you can be told to get the rate, okay? At time you'll be told to get the rate because you are given the rate, can't you see? At time you can be told to get the rate, okay? Now let's see one such situation where you'll be told to get the rate of pumping. Then that will be the end for this class, okay? Now let's go ahead. Thank you very much for watching, guys. Inform your family members and friends who are suffering in school, okay? To take part in this session, okay? Let them take part in this session because it will help them, okay? Thank you very much for watching, okay? Thank you very much for taking your time to see this kind of knowledge, okay? Without being discussed, okay? Let's go. You are not being discussed, okay? I'm helping you pray for my mom, Fatima Ali Muhammad, because had she not be on ground, had she not be on this planet Earth, Lord, pray for her, okay? Let's go. We are here to help each other, okay? Let's go. Let me help you. Make sure you also share this information with all your friends who are in school and family members because it will help them. Okay, let's see this example again. Let's see this one more example here. Okay, you're told a cylindrical. You're told, I think this is example of the way. Was this example 3 or what? Example 4? Let's go. This is example 3, I think. A cylindrical tank of diameter 2.8 meter and height 2 meter and height 2 meter contains water to a depth of 50 centimeter. Full stop. Question A. Calculate. Then from a 1 we have the capacity of the tank in liters. The capacity of the tank in liters. This is 2 max. Okay? The capacity of the tank in liters. Then from a 2, the volume of water required to fill the tank. The volume of water required to fill the tank. Okay, that's carrying again 2 max. Okay, then we have question B. We are told this question B. We are told water was pumped. Water was pumped into the tank. Starting at 11:25 a.m. to 1.15 p.m. So this time, the time when we started filling the tank, and the time when the tank becomes full. Okay, when the tank was full. When the tank was full. Calculate the rate at which water was pumped into the tank. Calculate the rate at which water, look at that, water was pumped into the tank. So this question is carrying 6 marks. Okay. Now let's go. What are you going to do? What are we going to do? Here, understanding the nature of the question is very important again. We are told a cylindrical. So this time we're going to sketch a cylinder. Okay? This is our cylinder. So the diameter is what? The diameter is 2.8. And the height is what? 2 meters. So the radius will be 1.4, yeah? The radius. So I know that volume is equal to by r squared h. That is by times r squared. R is what? 1.4, don't forget. Times h, which is 2 meters. So this is 0.2. So we'll have 2 times 0.2 times, look at this one, times 1.4 times 2. That is 12.32, yeah? 12.32 meter cubic. That is the volume of the cylinder, okay? We have told the capacity of the tank. Now, let's get the capacity. Capacity, I know that 1 meter cubic is equal to 1,000 liters, okay? What about what? 12.32 meter cubic. Cancel. So it will be 12.32 times 1,000 liters, which will give us 12 to 20 liters, okay? final answer. Then the volume of water required to fill the tank. Remember, we have, look at the depth of water is what? Is 0.5. So what you can do, that is what? 0.5 meters, okay? Let's say, up to this point, you have volume of water. Let's understand. It is 0.5. So you can say like this. If you want to get the volume left, you can say the volume left is what? The height left is what? If the total height is 2 meters and the volume of the height of water in the tank is 0.5, so you can get height left, which is 1.5. So volume left, you can say, look here. They say the capacity. They say the volume of water required to fill the tank. I can use an alternative method. You know, I can say I have what? I have the total volume, which is 12.32 meter cubic. So I can get volume of water in the tank, then subtract from the volume of the tank. Instead of saying that, I can also say the height of water, the height which is not filled to capacity is what? 1.5, because height of water in the tank is what? 0.5. Look at that. You will get the same answer. So the height of water, the height of the cylinder which is not filled to capacity is 1.5. So I can say volume required to fill the tank. Okay? Let me say volume of water in the tank. Let me say volume. Let me use this one. Volume of water in the tank. So I'll say by R squared again. I'll say, let me write the formula. V is equal to by R squared H. So by R squared times H is 0.5. So it will be how much? It will be how much? So by 7, 1 by 7, 0.2. So it's 2 times 0.2 times 1.4 times 0.5. That is 3.08 meter cubic. But you're told the volume of water required to fill the tank. Volume required to fill the tank. Volume required to fill the tank. It will be how much? Subtract 12 that 2, okay? 12 that 2 meter cubic minus 3.08 meter cubic. It will give you how much? 12.32 minus our final answer, that is 9.24 meter cube. This is the volume required to fill the tank for your information. The volume required to fill the tank is that one for your information, yeah? Just answer. But the rate of pumping, we need to get the rate, but what have they said? Calculate the rate of pumping water, calculate the rate at which water was pumped. So let me get let me cover this one. I'll say capacity. Capacity will be 1 meter cubic is equal to 1,000 liters. Yes. What about 9.24 meter cubic? Cancel again. It's 9.24 times 1,000 liters. So this will give me 90. 924. How many? 010 liters. Okay. Then after that, rate. Let me get time difference. Difference in time. Okay? Time difference. Time difference. That is, add this of 12. That's 13:15. Minus the starting time, 11:25. Carry 1 hour from this one, 60 minutes. Plus that one, 75. 75 minus 25 is what? 50. So here you're left with 2, 1. So it's 1 hour under this one. So which is 110 minutes. 1 hour and 50 minutes is what? Okay, 110 minutes. So rate of pumping. Rate of pumping. So give me volume divided by 10. Okay, which is 9240 liters divided by 110 minutes. So cancel this thing. 924 divided by 11 is how much? 924 divided by 11. 84. So we're going to say 84 liters per minute. Because our time is in minutes, okay? So we are going to say 84 liters per minute. Guys, unless or otherwise, okay, you have problem, okay? I'm done with the volume. Paper 1 questions, 10 marks, okay? This is how they frame during national exam in KCSE. That is the KCSE, okay? Of which students are right now doing, okay? So in our next class, if you will be pairing, if you will pair witness, if you will be there with us, in our next class we are going to discuss about integers of format. Please don't miss it because it's very helpful. I'll teach you the application part, how it's framed during a national exam, okay? We move like that. We will make sure to finish Form 1 concept in 1 month, okay? Then we will proceed to Form 2, where mathematics becomes what? Abundant thought. But I will be teaching you the application part in Form 2. You will not have problem. Very, very hospitable. And once you learn Form 1 and Form 2, mathematics, okay, of high school, then you will not have problem with the mathematics of what? Of high school, okay? And that is the end of volume, okay? We have done our best. Unless or otherwise you don't want to do research. Make sure you go and do research. Do past questions based on this topic. Then, God willing, in our next class, I'm sure 100%, we'll be catering for integers, okay? We'll be learning on operations on integers, okay? Performing of integers, okay? The cases, equation of integers, and so forth and so on. Until next time, I wish you the best, okay? And then next time I can say what? Cheers.